Assalamu alaikum and welcome to our channel. I am Dr. Hamad Ismail. In ligand protein docking, the induced fit docking is a very crucial phenomena. Today we will demonstrate that how you can perform induced fit docking in Schrödinger software. In this tutorial we will use protein 1kV1 which is P38 MAP kinase, which is already complex with I inhibitor, which means you can see this is the protein and this is the inhibitor. We will simply go to download and download the legacy PDB format. And the inhibitor we are going to use is iso-Y10X, which is a flavonol compound and has multifunctional in human body, which has multifunctional effects in human body. You can simply download it from the ChemSpider or the PepChem server. Simply download the mol file and you got these two files. Now I have prepared a folder on the desktop with name Induced Fit, and I have placed these both files in this folder. Now open your Maestro program. In today's tutorial I am using Schrödinger suite 2018. First of all, go to file and change working directory. From this, go to desktop. I have prepared a folder Induced Fit and I choose this one. And second step, go to file and create a new project. In the new project, I go to the Induced Fit and name the project as Induced Fit model. Simply Induced Fit, and I save it. Now I go to the file again and import structure. Go to desktop, Induced Fit folder, and I have one protein and I have one structure of ligand. These two molecules are now separated. I have two files. One is 1kV1, which is a protein which is already complex with a ligand. You can see ligand here. This is the original ligand, or you can simply go to preset and bioinformatics draft, which show you this is protein and this is your structure. Or you can simply right click and view in the ligand interaction diagram. It shows you about the protein and ligand complex. The second structure is our ligand, which we have downloaded it, which is iso-Y10X. Now I want to see either this ligand dock with this protein or not. And the method we are going to use today is Induced Fit Docking method. The Induced Fit Docking is considered as superior because of the accuracy of docking prediction due to protein flexibility at the binding site, which is used during this induced fitting model. Now we are going to perform it. At first step, we have to prepare the protein. Simply select the protein and then click on the protein preparation. If you can't find this here, simply you can go to the task and search protein preparation. So this is the protein preparation and you will see the protein preparation wizard. Normally it is present over here by default. As I told you, I am using the 2018 version of Schrödinger software, so I need to perform in step. But if you are using the higher version, then all the steps are present in a single place. So for 2018 user, first you have to press the pre-process button. It will pre-process your protein. Sometimes it shows that some side chain residues are present. It's totally fine, just press OK, it will fix for you. So you can hear the protein has been pre-processed. Here in the second step we have review and modify. You can see that these are two proteins which need to modify and one is BMU. If you click over here, you can see in the background which is its natural ligand, which is already present. We are not going to remove it because we will use it as a template for the grid box, which I will explain later. Simply, if you see something which is not appropriate, like 2 or 3 ligand is present, you can remove it here. but we are not going to delete it. And the next step is the refine. At the refine level, simply you need to first optimize. It will optimize your protein for ligand docking. It will take approximately 1 to 2 minutes to prepare your protein. Now the optimized job has been incorporated and you can see one more row over here. Now the last step is the minimization step. In the same refine menu we have minimization step. You just need to click on this minimize step and it will start to minimize your protein, which means the extra charges and the protein stability it will minimize so that it cannot affect your bonding states. It will also take about 2 to 3 minutes to complete. Once the job is completed, you can see an extra row over here in the workplace navigator. It will say that your protein has been minimized, which means then our protein is ready to work. Meanwhile, when you have performed this, you can close this window and the status of the running job can be seen over here. Over a job, you can see that protein is running, or you can in detail check the monitor like this one. You can double click over here and it will show you the status. Here our protein has been minimized. Now our protein is ready. As I told you earlier, if you are using the advanced version after 2018 Schrödinger version, all the steps will be on the single step. You just click to prepare the protein and you will see that protein has been pre-prepared. The next step is preparation of ligand. This is our ligand. Just click over here. This is our ligand. We want to prepare the ligand. Go to here in task and search lig prep and press enter. You can see here this is the lig prep wizard. You can open. Before going over here, just select this ligand over here, then go to this wizard and use structure from workplace navigator. This is basically our workplace navigator. So we have selected one entry, so you can see one entry over here. Second are the options, how you want to optimize your ligand. If you want to generate tautomers, you can also generate. I am going to disable this option because it will generate lot of ligand poses and generate the per ligand. I'm just going to click over here, generate one most active. That's it. If you create on to 10, 20, 30, it will generate different poses. Well, my target is not to see in the different poses, so I'm not going to take this option. And the last thing is ligand preparation. If you want to name it, you can name it. This wheel show you the options that how you want to prepare it. Well, I'm also not going to change it. Simply hit run button. You need to press the run button. It will start running your ligand preparation wizard. It say job is started. You can close this one and you can monitor over here that job is launched. You can monitor. This means here this is job is running. Your job is started. It will show you the activity of your job. It will take upon 3 to 4 minutes, sometimes 10 to 20 minutes. If you have used tautomers and you have selected more than 30 poses, so it will take time. Well, as I have not taken much, my job has been completed. It's finished. You can see it has generated two poses, one for this and this is for this. So my ligand is prepared and my protein is prepared. So in next step, you need to click on this minimize version and you need to go to the task. In the task button, you need to find out induce fit. You can see induced fit docking. If you cannot search it, go to browse, and in the browse you can see over here you have induced fit docking option. Click on it. It will open a new window. This will showing you what you are going to choose. When you have selected this one, it means your protein is already pre-selected. And the second thing is your ligand file. Currently it is on the ligand doc file. Go to the browse. In the browse, this is our folder in which we are working. We have changed the directory over here and we are working. When we prepare the ligand, it will generate a new file which is known as ligprep_1. This is the name which I given. Open it, and in this file we have out.maegz. You need to open this file and click open. It will import ligand from this. Now the second thing is our protein. The protein is already pre-selected. In this option, you need to choose the pick. When you need to choose the pick, when you click on it, in the background window it will show pick an atom to define the ligand, which means this is the place where you want to bind the ligand in the protein. Let me explain first. While look at this, this is our protein and this is the ligand which was already present over here. It is already docked. We are going to use it as a template, and we want the new ligand, our ligand which have been prepared over here at this place. So we are going this place a position where our ligand can bind. If you are not sure, you can go here in the preset and use bioinformatics draft. So it will show you that which is the ligand. When you have selected, just simply click on the pick and select one item from this one. When you will select, you will see it will generate a grid box around it, which means our ligand will only bind to this place, only this place which is ligand is given, which means the previously originally bind ligand will be replaced and our new ligand will use the same position to identify either they can bind on this place or not. So we over here again just click on the pick. We have defined the box. Now if you want to set the setting, go to gearbox. It is saying this is the name, okay, and just simply click on the run button. When you click on the run button, it will start your job. Depending upon the poses and depending upon the size, depending upon the tautomers, depending upon the different poses, it will take time. Well, one thing more I want to explain over here. I use the protocol as a standard protocol which generates 20 poses for each ligand. If you want a more detailed studies, you can choose the extended sampling. It will shift the poses from 20 poses to 80 poses, but it will definitely take more time. In my system is a 8-core system with 16 CPU. With this ligand and protein, it takes approximately 3 hours to complete. However, to make this tutorial, I have already done the job and I will show you the result of it. But if you keep it on running, it will generate you the result. You can see the progress of the result by going to jobs and go to monitor, and this one is job is running. Double click on it, it will show you the activity of the job, which means this job is being currently run. If you find any difficulty, if you find any problem, you will see message over here, or you will see the message has died, which means there is something problem with your ligand or your protein. If everything is fine, your job will be keep on running. Look at here, like ligand 1 residue list, which means it has identified the following residue as a potential to get to the target. So one by one it will start, which means it says number of jobs to be done is 38. Number of jobs in tree, as I have 2 poses, it will go to the 2 and it will keep on running, which means this is the, you can see the job over here. C is the number of completed jobs over here, A is the active jobs, and W is the waiting or pending job. which means it has 37 jobs to be done. Definitely it will take time to complete. So you can get an idea with the time by time it will keep on changing. When 0 will left over here, it means your job is near to complete. So you can get the idea how much time it will take and when your job is going to finish or complete. When your job will be completed, you will see the finish option over here. Now I just close this one and I upload the result which I have already generated and show you the result, that how you can identify or analyze the results. When your job will be finished, maybe it not appear over here. Sometimes the results appear in the workplace navigator, but if it is not appeared, go to the file, import structures, and here Induced Fit 1, this is the folder present over here, and from this open induce_out.magz, this file. It will import some structures and you will see some series of structure over here. You can see this is induced model fit 1, 21 structures are loaded and 4 structures are loaded. These 21 structure are for the 17 structure for one pose of the ligand, because I have two poses, one for this and one for this. Here 17 structure are for this pose, these 17, and 4 structures are for this pose. Well, go to the pose, it will show you the complex. This is the ligand and protein docked complex has been produced. If you want to see a better review, go to preset and bioinformatics default. It will show you the structure. If you move on here, you can see different poses. Or you can go to the preset and ligand side and select cartoon. It will show you the interaction like this one. You can move it, you can see the interaction. If you want to see a better overview, you can go to the bioinformatics default. The next thing we want to do, we want to see the comparison. Simply press the control button and select top 5 features 1, 2, 3, 4 and 5. I have selected the 5 features from here. Then go to the task and from the task search for interaction fingerprinting. So this is interaction fingerprints. Select over here. This window will show you two things, the dock poses and receptor-ligand complexes. Select the receptor-ligand complexes and click on the generate fingerprints. Okay, we need to select over here again. It says it's not ligand interactions, receptor poses and generate fingerprints. So it has been generated. Now click on the display interaction matrix. Now click on the color main plot. This ligand interaction shows that if we see on this line, it means ligand 1, 2, 3 or 5. They are all aligned, which means they are all binding to this ligand. If you click on over here, it will show you the information of ligand in this panel, in this area. If it will show you the ligand information. Similarly for this, if you click on this, it will show you the information, and this one and this one. It shows you that how much they are ligand bind to it. This is A85, A139, A202, and you can also save this interaction. You can save the figure, you can save the lines, or you can change the ligands, count of residues, or you can make any changes. From here you can see the type of contact, like you can see polar residues. What are the polar residues? It's showing the data for polar residue. Or you can see the aromatic residues, which are aromatic residue bind. these two aromatic residues are binds. Then you can see charged residues, these are the charged residues, and so on. You can also click on this one, which show you the interacting residue which are interacting with the protein. Samely, you can choose any interacting residue, so it will give you the graph. So when you place your mouse over here, it will show you here the complete information of that particular residue. Simply save this image and you can use this image for your thesis or your manuscript or what information you want. Here I just choose the 5 ligand interaction. You can also choose as many as you like. The next important thing is the table. You can go to the table, and from the table you can see it is providing all the information, like over here potential energy, RMS deviation, flags, tautomer probability, ionization potential, docking score, glide score, prime energy, and so on. Which information you like, you can see over here. One thing more which you can do, you can see over here. Simply I click on here and go to preset and click the bioluminosity draft. Click over here, it will show you the interaction, or you can simply choose over here the single one. Now again go to the table, click over here. From this option select single direction and click on the play button. Okay, we need to fix it. Basically we need to select take it from the start. Simply you have selected all these poses. Now go to table. From here select single direction and click on the first pose, and after that press the shift button and select the last pose. All these need to be shown to the blue. Now minimize this table and place on it a bit left. I also need to adjust this one to make a better view. Okay, now click on the play button. So you can see different poses are automatically showing and displaying their interaction, which means they are showing different interaction over here. Okay, we'll click on the pause. I close it. Now from this one I want to see the interaction diagram. Simply click on this one. If you are not showing this option, go to here in the plus sign and click on the 2D overlay. Okay, this option will be appear. Similarly, if you are not seeing this sequence analysis menu, simply go to its plus sign and click on the sequence viewer. It will show or hide. Now this 2D overlay is displayed. Right click on it and click on the view in ligand interaction diagram. It will show you the ligand interaction diagram. It is very beautiful image. You can use in your publication. Here you can select which type of interaction you want. You can select or deselect, or you can rotate it, or you can move it, or you can make it fixed, and finally click save the screenshot. When they save the screenshot, you can increase its width or height according to the quality you want. If you want a transparent background, you can click over here. Let's suppose I say 2000 and OK, and I save it in the Induced Fit folder. Then name it 1 and save it. Simply I close it, minimize. This is my folder and this is my interaction diagram. As I choose the transparent background, that's why it's showing like that. So in this way you can perform induced fit docking and choose the poses as you want. It will give you better accuracy with the result. If you have any question, please comment in the comment section. Thank you so much for watching this video. Goodbye.